the last thing we talked about in this chapter was how to solve a rational equation. We spent a lot of time simplifying things, but now when we put an equal sign into it, we actually want to be able to solve and get a value for x. If you only have one fraction on either side of the equal sign, you can cross multiply because then it's a proportion. Most of you guys are pretty confident with that one. If it's not a proportion, however, then what you need to do is find the LCM like you would if you were trying to make a common denominator. But we're actually not going to use it to make a common denominator. Instead of multiplying by only what's missing, like we do with adding and subtracting, we're going to multiply every fraction's numerator by the entire LCM. Okay? That's going to cancel out every single fraction. You should have no fractions left after that. So then you're going to solve whatever equation remains. Remember that it is possible for you to end up with a quadratic, and then you might have to solve using factoring or the quadratic equation. It's also possible that you might get an extraneous solution in that case, okay? It would be extraneous if it makes any of the denominators from the original problem equal to 0. We can't divide by 0, so that's what makes it extraneous. So here's a problem. I chose one that's not a proportion because I think we're pretty comfortable with proportions. So the first thing we need to do is find the LCM of all of the denominators. Now, the reason that we can't cross multiply on this one is because on this left side of the equation, because we're adding 2 together, we have more than one fraction. So for this one, x minus 2 is all I can get from that one. This one's a difference of squares, so we have x plus 2 and x minus 2. This one has an x plus 2. If I take one of everything from any of those lists, our least common multiple is going to be x minus 2, x plus 2. Okay, because I've got just a little bit of everything there. Now, let me go ahead and rewrite this just so you can see a little bit better what we have. We have 4 over x minus 2 plus 6x squared over, I'm going to write this in its factored form, x plus 2, x minus 2, and then that's going to equal 3x over x plus 2. Now, our LCM was x plus 2, x minus 2. So every single one of these, I'm going to multiply only in the numerator by the entire LCM, x plus 2, x minus 2. It doesn't matter if it already has both of them or if it's not missing anything. You're going to multiply by the same thing on all 3 fractions. Why did we do that? Because now we can cancel out all of our denominators. This one has an x minus 2, which was one of the things from our list. So all we have left up here now is 4 times x plus 2. The second fraction, I can cancel out both of the x plus 2's and both of the x minus 2's. All I have left is 6x squared, and that's going to be equal to the x plus 2's cancel, so I have 3x times x minus 2 left over. And now we need to go ahead and solve. First thing, we've got to distribute and multiply everything out so that we can combine our like terms. So if I distribute here, I get 4x plus 8 plus 6x squared equals 3x squared minus 6x. Now, I notice instantly that I've got x squareds. That means I've got a quadratic equation. We need to make sure that that gets to be equal to 0. So, I'm going to move everything based on what is going to keep my x squareds positive. So, if I subtract 3x squared from both sides, that leaves me with 3x squared. If I add negative 6x to both sides, I get plus 10x plus 8 equals 0. Now, we want to try first and see if this can factor. There is no greatest common factor, but we want to check, does anything multiply to 24? That's because of 3 times 8, and add to positive 10, and it does. We can get 6 and 4. Now, because this is a 3x squared, that means we have to do grouping here. we can't just write our factors. So I have 3x squared plus 6x plus 4x plus 8 equals 0. Split this up into two groups. I get 3x times x plus 2 plus 4 times x plus 2 equals 0. If you need help with factoring, go back and watch some of the factoring videos from chapter 4. And then we get 3x plus 4 times x plus 2 equals 0. Now that I have the factors, I have to ask myself, if 3x plus 4 was equal to 0, x would have to be, subtract the 4 and divide by 3, negative 4/3. And if x plus 2 was to equal 0, x would have to be negative 2. Now this is a case where we got two different solutions. And one of those might be great, one of them might not be, or they might both be good. What we have to check is we need to go back up to the original problem and look at all of these denominators. If I were to plug in negative 3/4, I would get some sort of weird fraction for every single one of them, but that's okay because it's not 0. However, if I were to plug in negative 2 in this one, I would get 0 for this denominator, which is what makes negative 2 an extraneous solution. So negative 2 is extraneous. The only good solution is x equals negative 4/3. Okay? Make sure that on your submissions that you clearly mark out anything that is extraneous because you can't submit it as a solution. Okie doke. That is all.